For the second component that we're going to work on today, for the second module of putting together this molecule, we're going to need another software program. This is the software program that we're going to use to convert our files from a PDB file to a STL file, which is a file that you'll need for the 3D printer, at least for the 3D printers that I work with. So what we're going to first do is I'm just going to show you where we would look to find this software program. The program is called VMD. It's actually this program here. You can access and get the software program itself. It's available through the University of Illinois. And that's where you want to go ahead and get that. You should be able to just go through here and find the graphics viewer and download that. And so I'm not going to explain that, but there's various downloads that you can use here. And that's going to allow us to open up the software program, which I will do now. So at this point, what we're going to do is we're going to bring in the file that we've been working on. We've got to first find the file, load it in. I'll close this window. The VMD workspace does take a while to get used to. It's got quite a bit of a learning curve to play with. I'm going to go through and just try to highlight a few different pointers here to try to help you work through it. One thing I'm going to do is I'm going to get rid of this little axis that's down here in the bottom. You can get rid of that by just going down under display and click on off on the axis. Now that's gone. The other thing I'm going to do is I'm going to go to the graphics representations, bring these over, and instead of showing these as lines, I'm going to show these as CPK. Under CPK, I'm going to have several settings that I will use. First one I like to go with is a sphere scale of 1.1 and then a sphere resolution of about 20. My bond radius, I go up to like 0.8 and 10. We're going to play with this a little bit, but this gives us something that we can kind of look at now. We've got this render. I'm also going to create a replicate of the actual skin that we're looking at. And that one I'm actually going to show only as bonds. Under bonds, I'm going to set that to 0.2 and leave it as 10. I'm going to go back to CPK. A couple of things you can do that's kind of nice here. You can double click on these and you can make them go away. So you can see just the bonds alone, or you can see just the CPK alone. Once I've done that, I can drop this bond radius down to 0 and put these in as two separate pieces. Sometimes if we do this, it makes it so that everything goes across into our next program a lot easier. Okay, so at this point we're going to go to the next step here, which is to try to do a rendering. Now to do the rendering, you've got to do a couple of things. I'm going to leave this open just so I can see it. I'm going to go down and click on render. It's going to open up this window down here. And we're going to tell it a file name. We've got to tell it what type of a render we want to do. We want to do STLs, triangle mesh only. And then we want to give it a name. We're going to call it this base pair AT-1. Then you got to make sure that at the end of this it says STL. The next thing we got to do is actually a little counterintuitive. We've got to scale this to a certain extent so we can go ahead and import that into the next software program that we're going to use, which is Tinkercad. So to do that, you have to use the command lines, and we're going to type in code that says scale to 6.0. One problem with doing that is you will no longer be able to see everything. If you want to see things, you got to go back down to scale to 0.1. You can see everything. But we're kind of blowing this up. And you kind of have to play with these settings to kind of get to something that works for you. And then we're going to come back here to the rendering controls and hit start rendering. And everything should be done. At this point, we need to go into our other program, which is Tinkercad. Tinkercad's a website you can go to. If you're going to work with Tinkercad, you've got to be doing that through a web browser besides Internet Explorer. For some reason that doesn't work. I tend to work in Firefox, and so if you run through Firefox, this should run just fine for you. We're going to actually create a new design. It's going to give us some kind of crazy name for that. That's fine. And then we're going to get ready to import this file. So now in Tinkercad, we're going to click on Browse. It's going to bring up our window, and we're going to find the STL file, which is right here. And we're going to import that. Depending on the size of the file, you may be waiting for a little while for the import. And it's always questionable just how nice the bonds are going to come across. Sometimes they'll come across just fine. Other times you'll have to do some manipulation. Under these conditions, our bonds don't look too bad. A couple of flaws here in some of the balls that are there for the hydrogens. And we might just sit and fix some of those. They don't look too terribly bad, but there could be some flaws. If you really get in there and look at that, you can see there's little pieces of those missing. And those may have to be manipulated by hand. One issue with the VMD software is, for whatever reason, when you import from that with the STL file over, you do sometimes get these flaws. But the benefit of using Tinkercad is Tinkercad seems to be able to figure out how to fix things, especially with some of the other programs I've worked with in the past, where you'll have your balls and your sticks here kind of coming together, and they'll actually be on top of each other. So when the 3D printer tries to deal with this, it prints things on one another, right? So it'll actually print over this area twice. If you work in Tinkercad, when you're all done, the file that it's going to generate for you, the final STL, will actually just be the skin of what you're finished with when you're all done. And that's one of the key benefits to working in Tinkercad. One thing we've got to do is we've got to kind of orient this for our print. So we've got to figure out how we want this to sit and look for the print. So one thing I'm going to do is try to minimize some of my space. It's all going to kind of depend on what's going to be the best option. I'd like this to be somewhat flat. So I'm going to come over here. I'm going to click on this, and this is a new feature Tinkercad's put in recently. I kind of have not yet decided if I like it or not. But if you really want to do your rotates, you've got to kind of grab the little dial here and adjust things on the outside of that. Otherwise, things look reasonable. Again, any empty space is stuff we've got to support here. On this side, things look pretty good, but on this side we've got a lot of empty space here. So if we click on this again, come over here, we can potentially adjust this way. What you can kind of see is we've got things in the plane. The benefit of that is now we can lower the plane. We don't want anything protruding through the bottom. So one benefit of being able to look through the plane is to see how everything is oriented. That's probably about as good as we're going to get to getting a nice flat surface here that we can manipulate. And at this point we're going to start going in and doing some manipulations. And what I'm going to do potentially is do a number of these manipulations ahead of time and then go through some of these with you just to describe how I do these. So this is going to be the end of this section of the tutorial, where we've now taken our file from our first software program. The program I used was Viewer Pro, then through VMD, and now into Tinkercad.